Oh no! The newly furnished conference room is broken. The TV is not receiving any signal, even after being connected. After inspection, it turns out that the two plugs of the HDMI fiber optic cable were connected in reverse. This is because fiber optic cables are directional. The source end should connect to the signal source, such as a computer, and the display end should connect to the display, such as a TV. They must not be connected in reverse. To fix this, there are two options available. First, smash the wall and replace the cable. However, this is too expensive and can be avoided. Second, exchange the exposed joints and carry out fusion splicing. I choose this one. Fusion splicing requires a professional telecommunications technician to operate. So, I called the telecommunications customer service first, made an appointment with a telecommunications technician, and then communicated the fusion splicing requirements with the technician, asking them to bring the necessary tools for on-site repair. Preparation of tools. First, I gathered the tools and equipment needed for fusion splicing: knife, fiber stripping pliers, fiber cutting knife, heat shrink tubing, PVC tubing, fusion splicer insulation tape. Preparations. I cut off the plug that needed to be replaced and peeled off the cable jacket. Then I used wire strippers to remove the internal cable jacket, and peeled off the outer coating of the bare fiber to expose the transparent fiber core. I inserted the heat shrink tubing into one side of the bare fiber. I used a cutting knife to cut both ends of the bare fiber flat. I fixed the bare fiber on the fusion splicer's fusion table. After peeling off the outer coating of the remaining bare fiber and cutting the end face flat, I put the bare fiber of the same color as the right one on the fusion splicer's fusion table and fixed it. I turned on the fusion splicer, selected Auto for the fusion mode, and selected SM for the fiber type. If the option is only I selected mode. I put the heat shrink tubing on the successfully spliced fiber and heated it. Repeated the above actions, stripping, cutting with a fiber cutting machine, placing a cut bare fiber on the left side of the fusion splicer, putting the other bare fiber of the corresponding color into the heat shrink tubing, fixing it on the right side of the fusion splicer table, and starting fusion splicing. I took out the spliced fiber from the previous section and let it cool. I could see that the fusion between the fiber and the heat shrink tubing was perfect. I repeated this process until all 4 fibers were spliced successfully. Next, I unwrapped the aluminum foil and exposed the internal copper wire. I cut a few sections of insulated heat shrink tubing and inserted it on one end of the copper wire. I peeled off the jacket on both ends of the copper wire, wound and fixed the 2 copper wires together, and soldered them with an electric iron to fix it. I put the insulated heat shrink tubing on the welded part. I heated and fixed all insulated heat shrink tubing evenly. Put the fusion splicing part and the exposed part of the wire into the PVC tube, and wrapped it with insulation tape to fix it. Now, the repair is done. Testing. Next, we plugged the replaced signal source end, plug into the laptop, and the display end, plug into the TV. The meeting signal was smooth and the image was clear, indicating that the repair was successful. Friendly reminder: if the plug is not reversed, and only one end of the plug is broken, you can also cut it and perform fusion splicing with a bridge wire. The steps are the same. If the first fusion splicing is not successful, you can try again several times. The above is the entire process of fusion splicing repair, and everyone can follow the steps to operate.